Why did we draw this thing? What topic are we in and what relevance does it have, apart from funny patterns, to anything we're learning in this course? What's the topic? Binomial theorem. What is a binomial? Binomial. Bi means two. Nomial means something with terms, right? So it's this thing. Right? So that would be, so more than one would be polynomial, right? Poly, many. So we're just looking at these guys. Things with two terms. And then when you raise it to some kind of power, and one of the first examples we looked at was 1 plus x to the power of 3, okay? So we can expand these things, and when we do that, we find that these numbers, these numbers from Pascal's triangle mysteriously appear. Just think of it. So, that's why this has appeared, right? But clearly there's some structure going on here, and we want to be able to talk about it. Number one, without having to draw out Pascal's triangle every time. And number two, in general terms, right? Now that's harder to wrap your head around. This is harder to conceptualize than this, right? Because I can write down the first number, but after I've written down my first number, I don't know what to write because I don't know what n is, so I don't know what row I'm in, so I'm stuck, okay? So I'm going to introduce some language, some notation, which will allow me to dig at this without even knowing what n is, okay? So, let me introduce this to you, let me define it for you, okay? Write this down with me. nCr is a number, okay? In particular, it's the coefficient of x to the power of r in this precise binomial, okay? I should say in the expansion of that binomial, but that's kind of implied, isn't it, right? So let me give you a nice, easy example stemming from this guy, okay? I'll write this up. We have all of the coefficients, 1, 2, 3, 4, and now I can write them without knowing what they're actually equal to using this notation. Okay, now pay attention. nCr, right? And I do write it with that funny superscript, normal subscript format, okay? nCr, the n refers to the power that I have, okay? So in this case, it's 3. So let's have a look at this one, this first coefficient, right? It's going to be 3c. Now, what will be this number down in the bottom corner? This r number. Now it's kind of hiding there, isn't it? It's the power of x that I've got, but in this case, the power of x is 0, isn't it? You see why mathematicians often start at 0? It's not just arbitrary. It actually makes sense in this context, okay? So that first number there, namely 1, right? That's 3c, 0. That's the definition of 3c, 0. This next number along, right, it's nCr, so the n is still that power, it still stays the same. It's going to be 3c, but the power has moved up 1, hasn't it? Okay, so this is 3c, 1. And now you can just kind of unfold the pattern from there. You've got 3c, 2 there, and hiding in there that 1 in front of the x cubed, that's going to be 3c, 3. Now I'm just going to pause for a second, just to caution you, because I know in this class there are going to be a significant enough number of you that you recognize that this means more than just what I'm defining it to be. It has a much broader meaning than what I'm starting with, okay? But I want us to start here, and we'll get there in time, and it will be confusing if we introduce it all at once before you understand how the pieces fit together, okay? So, if this is a particular example, remember one of the reasons why I was pulling out, introducing this whole language, is so I can start to generalize, and not just think about when it's to the third power, or the fourth power, or the fifth power, but to any power, right? So, let's write this out. What is 1 plus x to the power of n in this scheme? How would I write it? Okay, well, because it's starting with a 1, right? I could say it's always going to be 1. No matter what n I have, the first term will always be 1. But I can write it in a more helpful descriptive way, right? See how the number at the top, the n, that's staying the same the whole way through, and it relates to the power, right? So the first term should be nc0, right? So that top term is going to stay put. If you want to think about it this way, it's up the top just the same way the power is up the top, so you can sort of match them together. There's the first term. Now, the next term, the n stays the same, but I'm moving up 1 by the power, right? Which of course means there must be an x term that comes with it, right? And now my pattern continues. I'm going to have x squared. I guess I'd have x cubed, and so on. Okay. Now I don't know what n is, right? So this series of terms is going to go for some undeterminate amount of time. But it does end. It's not infinite, right? What will be the very last term on the end? Okay. So yeah, Mr.
That's the problem.
Okay. First, my x will be just like here. This power is going to match what you started with, right? And then secondly, I think Doris, you said it, the coefficient is going to be nCn. Okay, so that all matches up, right? So far, so good? Does that make sense? Okay. Now, just before I go into this and introduce sigma notation, on your calculator, which you should get out now, nCr notation, it's all right, you can see it on the screen. nCr notation is on your calculator. You might not have noticed it. If you go down to your big buttons there, right, and if you look on top of the multiplication and division signs, you see these operations hanging out there which you've never really paid attention to, right? You'll notice there's an NPR, which has nothing to do with National Public Radio in the US, and there's an nCr, which clearly, by the way they're set out, have something to do with each other, but we'll dig into that in the future. Okay, nCr is the one I'm interested in. So for instance, let's have a look at this guy. 3C0. I punched that in my calculator by saying 3, you're going to have to go shift, let's turn it on, that'll help. 3, shift 0. So you get that funny looking C, right, which is its way of indicating this, right? So I've literally written it 3C0, okay? And as we expect when you hit equals, you get 1, okay? So, for those of you who are kind of like, oh man, I have to keep flicking back to where I've drawn Pascal's triangle, I have to keep looking at this thing, right? Remembering that these coefficients match up exactly to these numbers, right? For instance, let's just do a quick experiment. How would you work out a term like, okay, so 462. That's the biggest number in my Pascal's triangle that I've drawn out, okay? What nCr does it correspond to? Now, do it slowly with me. What's the n stand for? It stands for power, right? Which in Pascal's triangle means it stands for row, right? That's the power that I'm interested in is the row that I'm looking at, okay? So this is the 11th row. Does that make sense? So I've got n equals 11 here. Now, which term am I actually interested in, right? There's two ways you can think about this. Firstly, I can just count them up, can't I? So I've got term 0, 1, 2, 3, 4, 5. Term 5 there, right? So this should be 11C5, right? Let's check it. Sure enough, okay? That was the first way. You could have just counted it out. There's another way of thinking about it. Before drawing any of this, if I tell you a row of Pascal's triangle, you ought to be fairly easily able to tell me how many terms there will be in that row, because they keep getting bigger, don't they? Right? For instance, the third row has 4 terms. The 7th row has 8 terms. So the 11th row is going to be 12 terms, right? Now, if there are 12 terms, watch out. I start from 0. 0. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now the question I posed at the beginning was I wanted the biggest term there. The biggest term in any row of Pascal's triangle will always be the middle one, right? In the middle, because there's symmetry to it, yeah? So some of them have one middle term. Why does this one only have one middle term? Because it's got an odd number of terms, right? So there's 1. It depends on if you're thinking about, n or the actual number of terms, right? So this is the nth row with n plus 1 terms, yep. So in this case, you can see it's going to be terms 5 and 6, right? The way that I would think about that, I guess, is the way I get middle is by bisecting, by dividing by 2, right? So that would be 11 divided by 2, right, which is 5.5, which tells me either of these would be fine. Does that make sense? Okay.